Okay, now we are trying to find the integral of e to the power x times sine x. You will see that there is a slight difference between the way of getting an answer for this problem when it is compared with the problems that we did before. Okay, uh, right now, in in the previous video I mentioned that when you choose something for you, say for example t squared, and if you differentiate t squared, then the power of t is being reduced. But see, in this particular case, no matter whether you select u as ex or u as sin x, there are no such reduction of powers, because when you differentiate ex, you will get ex. When you differentiate sin x, you will get cosine x, right? So there are no, like, these are almost the same thing. Even if it is sin x or cosine x, there are, like, it is not simplified by any means, right? So it's more or less the same complexity that they have. Okay, but in the previous video we did some problems where this simplified nature comes into play. Okay, but still, let's try to apply uh, integration by parts and see, let's see what's going to happen. Okay, so I will anyway consider u as ex and this portion as dv, and then when you, like, I'll do it quickly, du will be equal to ex dx, right? So by differentiating things, and here dv is equal to sine x. So when you integrate it, sine x dx, right? So when you integrate it, v will be equal to negative cosine x, right? That means when you apply integration by parts, the answer for this one will be equal to negative ex cosine x plus, plus is because you will have a minus here and minus will come out from the integral, which will give you plus, right? Because of this original minus in front. Ex cosine x dx. Now see, this is the place we started, and in the middle we are stuck with this integral, right? See, these two are almost similar, right? But it is not, like, it is neither simplified or no complicated, right? So it is not complicated than this one, and it is not simplified than this one, right? It's at the same level of difficulty, right? So what can we do for this one, right? Now let's try to apply integration by parts one more time, right? For this one, this portion, this particular case, let's consider this one as a new problem, and let's try to apply integration by parts for that section, right? So for that we will be using the same theory, I mean the same sort of substitution. This is equal to u and this is equal to dv. right? So then du will be equal to ex dx. This is e to the power x, and by doing the simplification, dv cos x dx. So when you integrate it, v will be equal to sin x, right? So this integral will be equal to, from integration by parts, ex sin x minus where is du? Yeah, this one, right? It's ex sin x dx, right? Okay, so this is the answer for this one. That means for this one, right? So what we can do is we can substitute this portion in here, right? Okay, let's see what will happen if when we do so. Then this one will become negative ex cosine x, and instead of this one I'm substituting this yellow color term, and then it becomes e to the power x sin x minus e to the power x sin x. Now this is a very special situation, okay? Because now see, we started with this problem, right? And then within the simplification, we have come up with the original problem, the original terms in our given problem, right? But the good thing is, here it comes with the minus sign in front, right? Now it's like if I take this one as I, what you will have is I is equal to negative ex cosine x plus e to the power x sin x minus I, right? So since this is an equation, we can take this minus I to the other side. Then it becomes 2I is equal to, if I rewrite this positive term in front, it will be e to the power x sin x minus e to the power x cos x, right? So I will be equal to e to the power sin x. If I factor out dx, it will be cos x over 2. See, now I will be equal to the given original problem, right? So this is a very special situation, right? We generated the original problem within the simplification steps, right? But now the good thing was that you get the original problem with a minus sign. But say for instance, if you get it as a plus I, then you won't be able to do anything at all, because when you have plus I here, that plus I with this plus I will get cancels out, then this will be equal to 0. Okay, so it will give some contradictory result, right? So this method will work only because you will have a negative I in this case, right? So this is a very special situation, okay? Especially when you have this ex and sin x terms, it's better to expect this sort of a simplification, okay? Right. And I did a big mistake here. You have to have arbitrary constant for the final answer. In the middle steps, it is okay to not to write the arbitrary constant even though you are using some integration by parts methods, right? So now, for instance, here you are using just direct application of integration by parts, right? So now it's okay not to write an arbitrary constant for the answer in here, right? But for the final answer, you must write the arbitrary constant. Okay.